Hello and welcome to this Smart Forestry webinar series, last episode for now. Today we're going to talk about the dynamic modeling of the value chain. We started up with the introduction to the Smart Forestry concept, which can be also understood as a precision forestry concept. How the digital inventory should be done and how accurate it can be with the current technologies. We talked about the simulation and optimization with that tree-level data. In the last episode, we talked about the supply chain management, how we can gain visibility to the machinery that doesn't necessarily have capabilities to send that information out. So today we're going to conclude kind of all that and go beyond measuring the trees and talk about the biodiversity and also the sustainability. With me, I have Jussi and Victoria from Simosol. I let you guys introduce yourself. My name was Jani Kaskinen. I'm Senior Principal at AFRY Management Consulting with the responsibilities on the digitalization aspects on the forestry sector. Jussi, please.
Thank you, Jani. So, hello from me as well, and welcome to the webinar. My name is Jussi Rasinmäki. I'm one of the founders of Simosol and CEO of the company, and have been working with enabling decision support for sustainable forest management pretty much all my working career. So this topic today is very, very close to my heart.
Very good. And Victoria.
Thank you, Jani. Welcome on my behalf also. My name is Victoria Polyachenko. I am the forest carbon expert at Simosol, and my core expertise is in forest carbon modeling and the substitution impact of wood use.
Yeah. So here are some of the layers and topics that we discussed previously. Any better?
Here we go. Perfect.
Very, very good. So yeah, I was talking about the layers that we've been discussing on the tree level inventory and monitoring, and using those multi-source data acquisition and combine that with the AI. We discussed about the monitoring pest disease and other damages, simulation and optimization, predictive analytics, leading to a site-specific management and IoT sensor-based tracking of the machinery and logistics around the wood supply and integration to the IT ecosystems and dynamic modeling. So within Simosol, you have a simulation and optimization platform, kind of making forecast and strategic and tactical planning for the forest assets. Now that we talk about sustainability and biodiversity, is that part of that platform, or how would you describe this?
Yes, it is. It is indeed. So if I'm looking back to the webinar series, we've been focusing very much on a kind of industrial wood processing supply chain and how to make that better, how to make it more efficient. But it's a kind of a traditional view on utilization of forests, and it is by far the most dominating form of utilizing the forest, of course. But now today we are kind of broadening our scope a little bit, looking beyond just the industrial wood supply chain and looking at the other services forests can provide, and how can we plan for those, how can we incorporate those into the other utilization of the forest.
Yeah, and before going into the content side, is that when you're measuring trees and the volume, that's obviously one thing. Is that same information then used for for sustainability and biodiversity aspects, or do you need more information to the platform?
That's the tricky part for this view of forests. Is one of the trickiest parts is getting the information out of the forest, and we will be talking about it a little bit more further down this webinar. But yes, there is a kind of a parallel line here. We started the webinar series with the digital inventory aspect, because when you are planning and trying to optimize the wood supply chains, you can't really do that unless you have good enough base information to do the planning on, and exactly the same phenomenon happens here. We need to have the information in order to plan for these things as well.
For sure, yeah. Would you say that let's say proper digital inventory enables you to also doing this, or is it a requirement?
I would say it is. It is. I mean, it's not come and solve all problems with this. It doesn't work. Unfortunately, it doesn't work quite like that, but it solves part of the problem for sure.
Yeah. All right. Going to the topic, so the global mega trends we're going to talk about today, and also measuring other aspects than the cubic meters. What are the challenges and opportunities there? We're looking at the existing solutions for doing that, and then we're going to conclude again with the take-home messages. So stage is yours. Victoria, do you wanna say a few words about the megatrends?
Well, gladly. We will go through the megatrends that have a most significant impact on forest and forestry, and these demonstrate that the future demand or the future interest towards forest is indeed diverse, sustainable, and it is long term.
Okay. Jussi, please continue.
Right. So if we then think about the megatrends listed here with particular thought on how they relate to forest, well, climate change is a kind of no-brainer, really. I mean, everyone knows the severity of that megatrend, and also how closely it relates to forests. And we will be talking about the concrete impact that has on planning for utilization of forest resources. Then we have a kind of, I would say, characterize these as a pair, the next two ones, accelerating urbanization and resource scarcity. So if you think about accelerating urbanization and the link to the first box, climate change, it's clear that we need to transition from non-renewable material sources to renewable material sources. Biomass and forests as one source of biomass is, of course, the renewable resource that can be used in economy. So there is a kind of strong driver for utilizing forests as a raw material source in future. But then we come to the resource scarcity point of view. If we have a kind of tunnel vision in utilizing forest resources, we are going to hit a wall with those, because then we are going to take away all the other aspects that forest provide. They are not just raw material resource banks that we can kind of deplete. We need to take care that they accrue interest as well and develop in a sustainable way. And then the fourth megatrend is a kind of interesting one, especially for us, because what we are doing as a company, we are actually part of this technological entrenchment, because we are creating these digital twins of forests and then use those digital twins for planning for forest utilization. But so we are, one could say that we are maybe if we consider this fourth one as a problem, we are kind of part of the problem, but it is an interesting trend in that sense that since we are using technology and digital tools so much in our everyday working life and also our leisure time, that there is this kind of upcoming trend of people perceiving nature as a valuable place where you can actually get off grid and you can get rid of the technology there and really unwind. So that's another mega trend that is really kind of driving kind of demand for these other services that forests can provide.
Very, very good. So looking beyond the cubic meters, what to measure, how to measure it, what are the markets, the legal frameworks, how to model, how to optimize that. Let's get into or dive into the topic, starting with the carbon.
Yes, so these three things we have highlighted here because we think that all three of them are needed in order to bring these other aspects of forest than roundwood production and industrial use of the roundwood as a raw material. They need to exist for this to happen. So first of all, you need to know what you have. Then you need to know, since forests they are not static things. If you know what you have right now, you have something different tomorrow and the day after that. So you need to be able to model how they change. And once you are able to know what you have and model how they change, then you can also kind of set goals and optimize your actions to reach those goals. So those two things we need to have. But if we don't have the third one, the markets, or the legal framework, then basically there is no demand. So you need to be able to put a value for things before it really makes sense to plan for those things. So as we have roundwood markets, for example, for forest owners, that drives the need for them to really know what they have, model how it changes, and optimize, for example, the roundwood sales. What's the best way to manage my forest for roundwood sales? The same way we need to have the markets for these different other services that the forest can provide in order for them to really become integral part of forest management planning, for example. So for carbon, we have, for the first 2 points, we have kind of given an indication for all of these services that we are going through, that how well established each of these aspects is. So for carbon, we know pretty well how to measure it for one part of the carbon, and that is the carbon in trees. But if we think about the carbon stocks in forests, actually the kind of biggest storage of carbon in forest is in the forest soil. And for measurement of forest soil carbon, there we are really kind of quite deep in the unclear territory. So we are what happens with the measurement is that we measure the forest, and here we have the obvious link to the digital inventory, for example. The better we measure the standing trees, the better we also know how much carbon there is in the forest. And we use this standing stock carbon as a proxy also for the forest soil carbon in a way. Here we come to the modeling. So we are using models to estimate the carbon stocks in soil, as well as we need some models also to convert the standing stock measurements into carbon ton measurements, because what we are measuring is basically all the measurements are geared towards the roundwood cubic meters. So we need some models also to convert the cubic meters into carbon in tree stock. And since we are able to measure somewhat well and also model pretty well as well, then we can use this as an optimization exercise to plan for forest management and in the carbon setting. But Vivi can tell us more about the remaining leaf there. What's the status with the markets and regulatory frameworks for carbon?
Yeah, it's an interesting one. I think it's been a while that we know how to measure the carbon in the trees, but yeah, what are the regulations around it? How should it be measured?
Well, I could start by commenting on the markets, because in terms of the voluntary carbon market, that is well established, and it is actually growing quite rapidly as businesses among nations are aiming for carbon neutrality. In fact, in last year we saw a surge in corporate climate pledges, which fueled record high offset transactions already last year, and this is expected to drive demand for carbon offsets already also this year. Framework-wise, the year 2021 is particularly interesting in the EU countries, where the new taxonomy regulation for sustainable investments creates additional incentive for forest carbon accounting. And here, the ongoing year should be the first reporting year for climate mitigation actions. Now, the significant deficit of otherwise encouraging voluntary carbon market are the double counting and then issues related to ownership, because forest carbon sinks are included in the national greenhouse reporting, while the carbon credits are often generated in private forests. So the same carbon is being accounted twice in some cases. We have the next conference of the parties coming in November, and there the role of voluntary carbon offsets in achieving nationally determined goals will be discussed, and that will hopefully shed some light on the future coexistence of voluntary carbon market and the national accounting.
Okay. What about the modeling and optimization then? How does that in a high level work you see in this remaining?
When carbon is considered, I would say, so it's kind of quite good situation in there, as said already from the measurement side, that kind of standing stock is a proxy, quite good proxy for carbon. Well, excellent proxy for the carbon in the living biomass, but then somewhat good proxy for the carbon in soil. But we have very good situation with the modeling side for the standing stock, because it's exactly the same modeling and optimization that we use for the roundwood production and roundwood estimation. But we also have pretty good models for carbon in soil, and here it's nice to be a Finn in that context, because one of the, I would say, the most widely used soil organic carbon model, it originates actually from Finland, so, but it's a global model, so it's not as detailed modeling and well established modeling as for the standing stock, but it exists and it's perfectly usable already today, and is used in all, I would say, especially it's in wide use in this regulatory framework, because this national reporting for carbon from the land use sector, it actually mandates you to also report the development of the carbon stock in soil, and these same models are being used there today also.
All right, going from carbon to a biodiversity. Jussi, how do we measure that?
Yes, we pretty much measure it the same way. same way as we do measure carbon in a way, but I would say that we have maybe forgotten to move the dot there or the button there a little bit more to the unclear direction than what it is there currently, because what happens here is that when we talk about biodiversity, it's a diversity of the species, living things in the landscape. Some of those living things have the unfortunate tendency of moving around and not being in one place for long. They are really tricky to measure. Then the plants, they of course stay there where they are, but they are also measuring, actually direct measurement of for example, plant biodiversity, plant diversity in the landscape. That's a really tricky measurement problem. So what happens here? Again, we are using these proxies. So we can measure, and we do measure for other purposes, the structure of the forest. And here I would say there is an even more strong link to the digital inventory that we talked in the first webinar, because there we talked about measuring the forest tree by tree, and we get the location for each tree, we get the size for each tree. So we have actually a very good structural diversity of the standing stock coming from this digital inventory. And this structural diversity of the standing stock of the trees is then can be used as a proxy for biodiversity as well, but it is a rather indirect proxy. So the measurement side for biodiversity is very much unclear, I would say. And then we have, of course, the kind of landscape aspect to it, how the structure of the forest varies when you move across the landscape. These are the measurements commonly used nowadays for biodiversity, because they are pretty much the only feasible ones in larger scale. Then what we can do on the modeling side, well, we can, of course, with the same models that we apply for the other purposes, for economical aspects of the forest, or for roundwood production aspect of the forest, for carbon of the forest, we can use the same models, and we see how the tree structural diversity of the forest develops. And then there are some kind of models that we can apply for specific species groups. Here we can apply a concept of a kind of indicator species. So again, a species forms a proxy for a larger group of other species. So if this species has these habitats that are suitable for it, therefore it follows that there are also other species that are doing rather well. So we can go on a modeling side, we can go to that extent already now, but it's not comprehensive coverage. I would say it's kind of a more spotty coverage. We can say something about some species, but not overall, in an overall picture, not really too much. But one aspect that we can bring to the modeling side and the optimization side is then taking other kind of directly measurable attributes of the landscape into account than just trees. So for example, what is the terrain like? What is the proximity to the water courses, things like it. So more features, kind of physical features of the landscape, and incorporate that into the biodiversity planning.
Yeah, sure. And I can imagine it's relatively tricky to forecast and model how the forest in biodiversity aspects look like 10 years from now.
Yeah.
But as you mentioned, there is indicators already existing, and I guess it depends how the forest is treated and so on and so on.
Exactly.
So you mentioned the landscape. That's an interesting aspect. How do you measure landscape?
Yeah, as you can see from the positioning of that button there in the bar, you don't. But you can again do something. So if we think, well, it's a little bit broad term here to use, but if we think of landscape from the kind of social point of view, if we look back to the megatrends that we discussed, this technological entrenchment, and then the need for nature experiences for people, then from this aspect, again, kind of covering the different aspects of the sustainability. So we have been covering in the webinar series the economic aspect of sustainability. Then we have the ecological. We just touched upon the ecological aspect of sustainability. So this is more like the social aspect of forest. Again, what makes it so hard to measure is the kind of personal views and opinions on this. So if you ask 10 people how they view or how they experience a certain landscape, you are pretty much, well, maybe not 10 different answers, but at least 3 different answers. So two different persons experience the same landscape rather differently, and that makes it almost nigh on impossible to measure. But we can definitely kind of model this to some extent, and what we can do thanks to this digital entrenchment or technological entrenchment, we can actually give digital tools to people to give their opinions on landscape and how the forest management changes the landscape rather well, because we can tap into the technical development that the game industry has had and build virtual views of a real forest, which are nowadays, some of them are pretty kind of photorealistic. So you can render a forest landscape that looks like a photograph of the landscape. And these tools can be, this kind of modeling can be used to gather views from people of how they view the forest management and the effect it has on the landscape. So it's not like we can't do anything there, but this is, of the 3, this is probably the trickiest one to put into the actual forest management planning framework.
Right. What about the markets or regulations around this?
Well, they do not exist per se, but landscape as well as biodiversity are supported implicitly through forest certification. For example, the PFC standard includes criteria for landscape maintenance also. And obviously these issues are largely interlinked. So biodiversity and also recreational values can be implicitly supported by the carbon market and other forms of environmental finance, either directly or through co-benefits.
Okay. All right. Then let's talk about the solutions that are existing nowadays on integrating these measurements and models to the work. Use, please.
Yes. So the first example is carbon, which comes as doesn't come as a surprise based on what we just saw. Though, if we look at the 3 aspects of the carbon, biodiversity, landscape, carbon is, I would say, by far the kind of most well-defined topic in those 3. So in that sense, it's easiest to integrate carbon in forest value chain because all the 3 aspects of it are somewhat well defined. So we have here just an illustration of the aspects you need to cover if you want to put forest carbon into the forest value chain planning platform or optimizing your forest management. So first part is, of course, what that line there represents is a kind of interface between atmosphere and the biosphere. So atmosphere is the up, and then trees growing are then down there and other things related to the trees growing. First part is, of course, how the trees assimilate carbon from the atmosphere to the structure. Roughly 50% of each tree consists of carbon. But it just doesn't go into the trees and stay there. The trees are living things, so they respire. So some of the trees that the carbon that the trees assimilate is actually going back to the atmosphere. And then, of course, when we as forest managers execute some silvicultural activities in the forest, there are emissions typically, because not everything is done with the manual saw and an axe nowadays, but we actually have machines in the forest working. So some carbon emissions originate from those, of course. Then the next step is like I mentioned, when we talk about carbon in forest, we simply can't talk just about trees, because the carbon storage in soil in some cases is really kind of overwhelming compared to the actual carbon stock in trees. So there is a lot of carbon stored in soil, and that of course comes from the trees growing on top of the soil and kind of pushing organic matter to the soil through litter fall and the roots dying in the soil. Again, the same phenomenon, we have the influx, but then some of it goes out because there are also organisms in the soil that decompose the organic carbon. So that's the kind of strictly forest part of this integration of carbon into forest value chain. But then we have the carbon that goes out of the forest as a form of harvested roundwood, finally ending in wood-based products. But we have a couple of steps in between the wood-based products and the carbon in living trees. So we have the emissions from the harvest and transport activities. Then we have the emissions from the manufacturing activities, converting the roundwood into the wood-based products. And then typically there are some side streams from this manufacturing that are used for energy conversion. So bioenergy production puts some of the carbon back to the atmosphere as well. So here we have the kind of and then we have the recycling activities as well. So here we have the full forest carbon cycle as such, but then it has a kind of a side phenomenon that Vivi can talk us through a little bit more in detail.
Yes, thank you, Jussi. So lastly, we can also take into account the avoided emissions, which is more commonly referred to as the substitution impact of wood use. And this indicates the potential climate impact that arises when wood material is acquired to substitute some fossil intensive alternative. Now, the avoided emissions or the substitution impact should be seen as a dynamic indicator of the mitigation potential of wood that can be improved by changing the wood use pattern. And it should be used above all to support decision making rather than improving the overall balance. It's kind of like an indirect impact.
So it's linking when we think about carbon in forest value chain, if we kind of isolate the value chain from the rest of the society, rest of the economy, we are really kind of looking at a kind of partial view of carbon, forest carbon, because it does have these indirect effects also if we are using the wood-based products. So it's, in that sense, it's a very important part of the big picture.
Yeah, so not only measuring the timber and the usage of that, but also knowing the end products and whether they have a substitution potential or not.
Yeah, exactly. So
Very good.
that was what we need to do in order to have something like this. So it was a kind of description of from the modeling side of view, and now we are coming to the actual kind of, I would say, maybe the market aspect of it. Now, how we convert what we have measured into numbers, into figures that can be used in decision making. So here we have a kind of typical forest management planning setting where we have created two scenarios of how we manage our forest, how we utilize the forest resources, and then we are looking, in this example, we are looking at a 20-year time frame for the future. If we are going for the next 20 years, if we are going to act like this is what is going to happen, and we are comparing two different scenarios, how they differ in the carbon stock in biomass, but also how they differ in the carbon stock in the harvested wood products, because like we saw in the previous debate, it's not just about carbon in trees, carbon in soil, but we have a third carbon stock as well, and that is carbon in harvested wood products. So these figures are interesting on their own right, especially at least for the forest planning experts. But then what we have on the following page is interesting for a wider audience, and this brings us to the point that we were making earlier on in the presentation, that you need to have these three aspects. You need to have, for something to happen for real, you need to be able to measure, you need to be able to plan, so you need to be able to model, but you need to have markets that give some kind of economic value for carbon, for example. So here we have a scenario analysis from the point of view of the markets. So we have a business as usual timber sales scenario for a forest owner. For this time we have a much longer time frame. We have a 90-year time frame, and we are looking at the cash flow generated that the forest asset generates for the forest owner. And the purple bars describe this kind of common current practices where the revenue comes from the timber sales alone. And then the green bars, they show a kind of alternative scenario where we are thinking about credit income from carbon credit sales plus the timber sales. So we are really coming to the kind of multi-objective planning, or kind of more multifaceted planning than just timber sales planning alone. And we can see that the effect, in order to have carbon credits to be sold to the markets in this kind of scenario, we are giving something away from the timber sales. So the darker green bars are shorter than the purple bars. So the darker green bar is the revenue from the timber sales in this alternative carbon credit scenario, and then the lighter green bar on top is the carbon credit sales revenue. And you can see that it's not by far the dominant factor in this scenario at all, but what it does, it provides this additional income that actually pushes the revenue higher than the timber sales, than in the scenario that is based on the timber sales alone. And this kind of thing, then at least for me, really kind of only when we get to this point, it really drives the message home that, okay, I need to change something in order to do better. Prior, when we are still in a stage where it would be nice to do something, that doesn't really convert to actions in at scale. But when we can show that this is how if you are kind of acting rationally, this is what you need to do, then that converts into actions.
So in this, we can see that the crediting system works and how it works. So yeah, and seeing is believing. So
yes, but we can also see that it actually, in this particular setting, it actually works as a change driver only where you have a pretty high carbon credit price. You can see there that in this scenario, the carbon price has been 30 euros per tons of CO2. That is a fairly high carbon price traditionally, but carbon credits are not quite like Bitcoin, but they have some similar features, have shown some signs of similar features that the carbon credit price, it's very hard to kind of predict what it will be in next year or 10, let alone 10 years from now. So it's kind of a unknown factor here, but at least we can see that, okay, it needs to be at this level for it to really have an effect on how things are done. And there is that black capital letters note down there that of course, it depends on what the structure of the carbon crediting scheme is, how it converts to euros or dollars. And one has to be really careful when drafting these carbon crediting schemes so that they actually serve the purpose for which they are created for. It's possible to, and it's quite easy actually, to create a carbon crediting scheme where the climate benefits are not really fully realized. So that's a kind of cautionary note there that this is a tricky subject matter, and it's not very easy to get it right.
Yeah, that's for sure. But it's also kind of looks to me that you can adjust the level of an impact with it as well. So in that sense, the mechanism is working potentially better than a Bitcoin, which is in a deep dive right now and very sensitive for the tweets.
Yes, yeah. That's definitely different. I don't think the carbon credit schemes are really kind of tweet-driven phenomenon.
Very good.
Right. So now we are on a home stretch of this webinar. So this is kind of putting everything together. So we have been kind of building up different aspects of this integrating the ecosystem services to the forest value chain, but it's just talk until you have something that you can actually do something with. And we have just showing here one existing solution where we are actually integrating multiple objectives and kind of in a way that the forest owner, forest decision maker can be on the driver's seat saying that, okay, I have different objectives for my forest asset, and I want to find an optimal plan for management that realizes these objectives. And in this multi-objective setting or solution, we have 3 different categories that you can set. You can set for economy or profitability, how important it is, how important is carbon, and how important is I would say, biodiversity for the forest owner. And then once the forest owner makes the decision, they can see what they should do with the forest asset. So it's a practical decision support, what to do with your forest.
Yeah, and this looks like a very good kind of tool or way for a small forest owners. But what about the because a lot of the audience is enterprise companies with very vast areas of forest. I guess there is more granularity on the decision than let's say 3 levels.
Yeah, this is a kind of usability question. So how much you aggregate, or how much you simplify the decision problem, or how granular you bring it to the decision maker. So I would say this is on the extreme end of simplifying the problem setting and how to deal with it, and how to make it as simple as possible for the decision maker to make decisions. But yeah, it can be then ripped apart to be more detailed, of course.
Yeah, to find the optimal solution for any kind of use.
Yes.
Did I lose the screen? I'm kind of blinking screen here. So how does it look like in the management kind of level in the system? Can you talk us through this? We have a few minutes left, so.
Yes, this is what happens then when you set your goals and then you run the optimization for your forest asset. Here we have a very small asset as an example, but then the practical problem from the kind of decision support point of view, how do you then show the results to the decision maker in order for them to make their decisions? And here we have two components which are very common in forest management planning. We have the map component, and then we have an aggregation of the data that shows the kind of critical features of the solution to the user. So you can on the right hand side on the map, you can see really the details, and then on the left hand side you can see the big picture. And the details showing on the map are the markers on the map. They actually convey a message. The red markers are kind of indicating urgency. There is something you need to do in the forest right now. Go there, execute this if you want to reach the goals that you see on the left hand side. And then the green and gray markers are saying that, okay, these are not urgent actions. You can look what they are, but they are further along in time for you to act on. And then on the aggregation view, the basic idea is that you can compare your scenarios. So the current plan that you had put your goals to be multiple goals, so you have some weight for one attribute, you have some weight for economy, then you have some weight for biodiversity, for example. You can compare to that to the traditional single object plans, for example, here from the profitability, that how much you need to give away from income in order to reach more, for example, biodiversity and for carbon. So you can compare. It's always a kind of a negotiation. You have to give something away to gain something. You can't just give maximum everything. It's just not in the nature of forest.
Isn't the compromise a definition that both sides will lose something?
Exactly, yes. But the one aspect still about in order to be able to do this, you have to be able to put the different goals on a same scale. So you have to convert them into something that you can talk in common terms. Quite often the common term is euros or dollars, but it can be also something else. But anyway, the message is that you need to, in order to do something like this, you need to be able to measure and model.
For sure. Some of the takeaway messages to kind of conclude this this webinar is that the climate and societies are changing. Forestry sector is certainly important in this area, but it also needs to adapt to it. Regulations and the frameworks around it, as far as the markets, would it be fair to say is certainly emerging, if not ready, in many places, and will start driving these values further, and will start affecting the decision making. Science-based indicators in combination with technology can be used for future planning, and there are solutions already existing in this area, as well as we discussed in the earlier topics. There are a lot of technologies available. It's a matter of combining those and making the best use out of it. I want to thank you all in the audience again for being with us. It's been a great pleasure. We've had 5 different webinars on the topic of smart forestry. This is the last one. However, we are likely to continue at some point. And if you have, we've got a lot of feedback. So if you have any ideas or you want to deep dive into certain areas, please send a message, and we can certainly consider to have a specific webinars as well on the topic. So thank you on my behalf, and you all have a great day.
Thank you very much. Hope to see you someday again. Bye-bye.
Bye.